In the previous movie, I described how to work with permutations, that is, sets where the order of values matters, without duplication. In this movie, I will show you how to calculate the number of possible permutations when duplication is allowed. As before, let's assume that we have 8 speakers who are available to speak at a company event, and we want to choose 3. However, it is possible that we can have the same person go twice. So in other words, duplication is allowed. I do want to emphasize that order still matters. So having the same person go first and third is considered a different permutation than having a person go first and second. So once again, order still matters. So our question here is, how do we calculate the number of unique orders that are possible when choosing 3 of 8 people when repetition is allowed? To demonstrate the process, I will switch over to our Excel sample file. I'm now in Excel, and I've opened our sample workbook, which is 0605 Permutations with Duplication. You can find that in the Chapter 6 folder of the Exercise Files collection. I have defined our scenario with 8 available speakers and 3 available speaking slots. And for comparison, I left the value from the previous movie, Permutations without Duplication, in cell B6, and remember that that is 336 possible orders. Now let's see how many we get if we have permutations with duplication allowed. So I'll click back in cell B8, type an equal sign, and the function we will use is permutation A. That is the second one available here after I type in PERMU. And permutation A returns the number of permutations for a given number of objects when repetition is allowed. So I'll press Tab, and the number of possible items is B3. That's the collection we're choosing from. Then a comma, and the number chosen, in this case the number of available speaking slots, is in B4, right parentheses and enter, and we get 512, so significantly more. However, it is limited by the number of open speaking slots. In the previous movie, I asked what would happen if we had 10 available speakers and 5 open speaking slots. So I will change the value in B3 to 10, and we'll go from 336 and 512 to 720 and 1,000, so quite a few. And if I increase the number of open speaking slots, we go from 720 and 1,000 to 30,240 and 100,000. Mathematicians call this combinatorial explosion, and I think you can see why, because the numbers get very large very fast.